sometimes you will be given some functions which they're the combinations of two other functions. Since you need to deal with the composition functions, that is why you need to take their derivative, okay, for your problems, for your applications. But we don't know how to take the functions if you are given, right, in a composite way, since the rules we have learned so far, right, the differentiation rules, quotient rules, product rules, right, some other rules, simple rules, doesn't help us, okay, to take the composite functions derivative. And sometimes we may not be given the composite function, but we can represent the functions, okay, we are given in a composition function way, since it is going to be simpler to deal with. Let me give you an example, okay, what I mean by that. Look at this example. If I gave it to you, this function, 3x cubed minus 7x plus 1 to the 15. Do you see? This is the polynomial, and then you have the right the power 15. What would you do? And then if I ask you, please can you give me right the derivative of this function? What rule would you use? Is there any rule you can use? You can say that we can write the FOIL it down. That would be so painful, right? The taking the 15 power of this one, the multiplying all of them, and then take the derivative. So that is why we need to find a simpler way, right, to deal with this type of functions, derivatives. So this is, okay, what we call the chain rule, guys. So let's look at the rule, okay, now we're going to solve the similar examples like this one. Let's say we have this type of functions, g of x, right? And then as you see, this is a composition of, right, the f of g. This is the function of composition of f and g. If I would take the derivative of this function, that's going to be given, okay, by the chain rule in this way. F prime, g of x, and g prime x. Okay, that's what we call the chain rule, guys. I'm not going to prove this one, okay? This is the rule we need to apply. We have another notation, okay, for this rule. Sometimes we may prefer using that one. If you say u is equal g of x, I can turn this formula, look at this one, since I know that I have this notation as well. Since if you take the derivative of u, that would be equal to du over dx, right? Which is equal g prime of x. If I use this notation instead of this notation, this formula would turn into, look at that, the derivative of dy with respect to x, right? That is the derivative I'm trying to figure it out. Then look at that, the derivative of f with respect to u and the derivative of u with respect to dx, correct? Since this is equal that one, and then as you see, right, since this is going to be u, and then the derivative of prime u I can represent in this way, and then the left hand side is going to be this one. So what I can say that I have two versions of, right, the chain rule. So chain rule, okay, version 1. So chain rule version 2. You may prefer both of them, and you can use either of them. And sometimes, okay, using the notation you see in version 2 is going to be better to prefer, okay, for some question. So keep in mind, whenever you see these two rules, they are same, they are chain rule, and then you need to use for the composite function. So let me show you a couple of examples how we can apply the chain rule to the questions. So basically I can start with the question I just asked you, even though I don't remember exactly, but we can get the similar one. So 3x to the 5 plus 7x minus 1, 15. I think that's the one, right? That was similar. So look at that. Is there a two composite function here? Yes. What are they? I have, look at a power function, and then also I have a polynomial function here. So if I call this one, right, which is f of x, right? And then my g of x, f of x, is equal to 3x5 plus 7x minus 1. And then my g of x would be equal to this function, right? G of x would be equal Let's look at this example and see the composition of two functions here. If I have this function, look at that, my f of x would be, right, the outside function. So f of x here, right, would be something like that, x to the 15. So you can say this one outside function, okay? You can give the chain rule actually in this way as well. And then your gx would be, right, equal to the whatever you have inside. So as you see, there's another function here I can call, which is g of x, 3x to the 5 plus 7x minus 1. This is the inside function, guys. If I combine the inside function by outside function, as you see, I would get my function. That is why, right, we can use these two functions to get, right, the y in a composition of f of g. So that is the first step, right? Step 1, you need to determine, right, the two functions so you can get, right, the original function. So in step 2, I'm just gonna, right, apply my formula. My formula was equal dy over dx, which is equal df over du, and then du over dx. Who is here the du, right? U is, right, this function. Okay. So what is the f? F is equal x to the 15, but as you see, to get, right, the y, I should be changing the x by u. That is why I'm gonna take the derivative of f with respect to u instead of x. If I take the derivative of this function, and then I also know, right, that the u was equal 3x to the 5 plus 7x, 3x to the 5 plus 7x minus 1. And then I should take the derivative of this with respect to x. You can write in this way, okay, as a subindex. So let me take the derivative of this, which is 15 times u to the 14 using power rule. I'm going to also use the power rule here, 15x to the 4 plus 7, and then the derivative of 1, which is equal to 0, since it is a constant, as you know. And now look at what happened, right? I'm done with the derivative, but at the end of the day, right, who was u? U was equal to, right, the g of x, which is, I know, 3x to the 5 plus 7x minus 1 to the 14 times the derivative of u, which is equal 15x to the 4 plus 7. As you see, it is easier than, right, foiling it down. As you see, I just took 3 steps, or maybe you can do it in a 2-step, right, to get the derivative of this complex function. So that is why, okay, we need to use the composition, which we call the chain rule here. So it is easy to apply, but you need to be careful how you obtain the composite function. Let me solve one more example for you. 3 times 2 square root x plus 5x squared to the the 8, we can say it. Okay, when you look at this function, first of all, you need to notice who is outside. So the power is going to be always outside function. As you see, this is my outside function, and this is my inside function. So inside function needs to be called u, right? 2 square root x plus 5x squared, and an outside function can be given by, in this way, which is f of x, right? F of x is equal x to the 8. So how you combine this, right, to get the y, you should combine in this way. Y is equal, right, f u, as you see, right? If you combine f of u, it is going to be equal u to the 8. U was equal this function, and then you should do it in this way. So, okay, you are asking about, right, the 3. 3, you can ignore it, and then you can just put there, guys, okay? So it's not a big deal, okay? As you see, I have this function, and then I can take care of the derivative using the chain rule. I know that. dy over dx, that is the derivative I'm trying to figure it out, which is equal to df over du times du over dx. And then the derivative of f with respect to u, which is equal, as you see, 24 u to the 7. Who was u? Let me go ahead and then take a look at it, which it was 2 square root x plus 5x squared. I need to take its derivative. If you remember, right, what was the derivative of 2 square root x, which was equal 1 over 2 square root x plus the derivative of 5x squared, which is equal to 10x. If you apply the power rule, that's it, right? 2 will go away, and then u was equal now 2 square root x plus 5x squared, and to the 7 times 1 over square root x plus 10x. This is how I took the derivative of this. As you see, I just applied the composition rule, okay, in the same way.